a white color of light incident on it. So at the top it will be what, red, and at the bottom so it will be what, red, and it will be violet. Okay, so here okay, so what you can see here a white ray of light will incident on the surface AB, okay, on a prism. Now it will be split into 7 different colors as an emergent ray. Okay, so the top side it will be red and the bottom it will be violet, and in between all the other 5 color of lights will be there, and yellow will be there at the middle. Clear? Now this ray, so here base is downwards, and here we have attached another prism, we place another prism in which the base is upward. So now this ray, when it will be refracted through the prism, what, it will move towards the base of the prism. The base is upward, so it will also move towards the up. Here, and what will happen, all the rays, see, the red and violet are mixing, and all the 5 color rays will also mix. Okay, and what, ultimately if we place one curtain, we will get the white color of light. That means what, here the light is splitting, here the splitted light is again meeting together and prepare the white color of light. That is the reason. Okay, the prism actually cannot create any new color of light. It is only splitting the 7 different color of light. As the velocity of light in the glass medium are different, that's why the refractive index of 7 different color of light will be different, and so angle of deviation will also be different. Okay, that's why each color of light will be deviated at a different angle, and they will be splitted among each other, and they will come out. So angle of deviation will be minimum for the red color of light, will be maximum for the violet color of light. Okay, so that's why the red color will be at the top and the violet will be at the bottom, and in the middle the yellow color of light will be there. Okay, so I hope you have understood this experiment. Now also one experiment was performed by Newton, that is known as Newton's color disc experiment. Okay, there what the scientists have done, one circle, okay, so it will be split into, suppose it is red, okay, and all the 7 different colors of light, okay, so it will be arranged. Okay, so the circle will be split into 7 equal parts, and each part painted with 7 different colors which are there in white ray of light. Okay, video. Okay, so it will be given the 7 different colors, and if we rotate it, okay, very rapidly, okay, then what will happen? We cannot, when it is still, it is not moving, we can identify the 7 different colors very easily. Okay, if it is kept in front of our eye, if we keep this in front of our eyes, then what will happen? We can easily see the 7 different colors. But if it is rotating rapidly in front of our eyes, then we will see the color of the total disc is white. Okay, why? To understand the reason, one term we have to understand, it is persistence of vision. Persistence of vision. Okay. What is persistence of vision? If any image is there inside our brain, okay, image is formed in the retina, okay, inside our eyes, so that image will be transmitted to the optic nerve to our brain. Okay, so if any image is there, then the effect of the image, okay, it may be a color of light, it may be any object, okay, image of any object. So the effect of that object will be there in our brain for 1/10 seconds. It will be for 1/10 seconds. Okay. If within that time period, shorter than 1/10 seconds, if any other color of light or any other images are formed in our brain, then our brain cannot identify that separately. Okay. So this time is known as persistence of vision. Okay. This time is known as persistence of vision. So when the disc is rotated at a rapid speed, then within 1/10 seconds of time, all the colors of light are entering in our brain. So as a result, our brain cannot distinguish the different colors, okay, within that short period of time due to the persistence of vision, okay. So all the color will be mixed inside our brain, okay, and we will see as white. Why? Because white is a combination of 7 different colors. So that's why all the colors of light will be there in our brain in a time period within 1/10 seconds. Okay, as the disc is rotating very fast. Okay, so for that reason, okay, our brain cannot distinguish the 7 different colors. Okay, so all the colors will be mixed. Okay, that's why we will see the disc as white. Okay, so this is the experiment done by the Newton to show that white color consists 7 different colors. Okay. Clear to all of you? Okay. Now, what is the range of vision? Okay, the range of vision. Actually, white color of light emits, okay, the color which have different wavelength, okay, which have different wavelength. All is not visible, okay, all is not visible by us. The wavelength we can human eye can visible only 4000 wavelength of 4000 angstrom to 8000 angstrom. In between, whatever the color of light lies in between, we can see that, okay. So it is what? It is violet and it is red, and all other 5 colors will lie in between. Okay, so that's why we can identify the 7 different colors. So white color, so our range of vision is 4000 angstrom to 8000 angstrom wavelength. Okay, for the different color of light. If the wavelength lies in between, then only we can see that. Okay, if the wavelength is not lies in between this range, we cannot see that. Our eyes cannot see that. We cannot identify that. So that's why the 4000 angstrom is for violet and 8000 angstrom wavelength is for red. That's why, and all the other 5 different colors are in between these two. Okay, so that's why we can only see the 7 different colors. Okay, which is actually there in a white ray of light. Okay, so this is the range of our vision. This is the range of our vision. So now, our next topic is angular dispersion. And dispersive power. Okay, angular dispersion and dispersive power. For a thin prism, okay, if the refractive index of the material of prism is mu, okay, it's for a thin prism, okay, for a thin prism, okay, then what we know, angular division delta is equal to mu minus 1 into A, where A is the angle of prism. Okay, A is the angle of prism. Now, suppose the angle of deviation for red color of light is equal to delta R, and refractive index mu1, and for violet color of light is what? Delta V, and refractive index mu V. Okay. So yellow is what? It will be in the mean position. So let angle of deviation for yellow delta is equal to what? Mu minus 1 into A. Okay. So angle of deviation for red will be what? Delta is equal to mu1 minus 1 into A, and angle of deviation for violet delta V is equal to what? Mu V minus 1 into A.